11.4 talks about shifted conics. So we start with an example right away. Example 1. Sketch the graph of the given conic. So it could be either a parabola, a hyperbola, or an ellipse. Label the center, vertices, foci, asymptotes, and find the length of the major and minor axis. So depending on what you have, label the center, vertices, foci, asymptotes, Directrix, and find the length. So every combination we can think of. Well, let's start with the first problem. So I'm going to show you two ways of doing this. It's up to you. The way I'm going to do this, well, I'm going to solve. That's how the book writes the equations, because of the way they find the standard form to them is different. We just use, hey, divide by 4 both sides. We just use the traditional shifting of conics from chapter, I forgot which chapter it was. When did we do graphing? Transformation, chapter 2, 2.6. So y equal x minus 2 squared plus 1. Well, I know how that goes. That's a parabola shifted 2 units to the right and 1 unit up. And I just want a rough sketch. There it is. So I need to label the vertex. The vertex is really 2, 1. Now, oops, I forgot the 4. Okay. Now, if I take 1 over 4 and set it equal to 1 over 4p, cross multiply, p equal 1. 1 unit above will be the focus, and 1 unit below will be the directrix. If a problem is this simple, I really don't need any alternative methods. I could just say, well, let's see how that works. That is at 2, and 1 above, that's at 3, 2, 2, I'm sorry. 1 above 1, that's at 2, and the directrix is y equal 0. Done. Looking at the second example, same deal. I want to solve for y, for x in this case. So I would subtract 4 from both sides, divide by a negative 2. Now, we're not used to x equal y, so I'm going to give you an alternative. Again, I have no issue with saying, look, I know negative y squared looks like this. The plus 3 is going to shift it 3 units down. And the 2 will shift it 2 units to the right. I have no problem doing that because I've been doing that forever. Now, you on the other hand, if you're used to that and comfortable with it, you do it that way. If not, this is my alternative. Switch x with y. And the reason we're doing that, even though it looks like it's a lot of work, it's much easier to play it safe and get it right. We're used to y equal, we're not used to x equal. If I look at this graph, I know the vertex is at negative 3, 2. Negative 3, 2. The reason I'm not really making that very accurate because it's an extra graph that I don't need. And the parabola opens down. We got it. We want the focus. We know it's going to be at x equal negative 3. And the directrix is y equal. And let's see how that works. We're going to take 1 over 4p and set it equal to 1 over negative 2. That indicates that for p equal negative 2. P is negative 1/2. So here I am at y equal 2. I'm going to move half a unit below. If I am at 2 and I move half a unit below, 2 minus a half is 3/2. And I'm going to move half a unit above 2, which means 2 and a half, right? 2 and 1/2, that is 5/2. Now, even though, again, this seems like a lot of work, but it does worth it if this is very challenging for you, in the sense of, now, to figure out the vertex, switch the x with the y just like we did right there. So that's 2, negative 3. I have a graph of the vertex at 2, negative 1, negative 2, negative 3. I have a focus, switch x with y, at 3 halves, negative 3. 3 halves is negative 3. The focus is right there. I know the parabola must include the focus in it. And the equation of the line, switch x with y, 5 halves, there's the line L. And I think that worth that, even though we did all of that extra work, but I think it's worth it until you get the hang of this. Here again, I'm looking at y equals negative 2 into x plus 1/4 squared. Hey, I know what that is. That's an upside down parabola. I know the vertex is at negative 1/4, 0. So the vertex is at negative 1/4, 0. If this is negative 1, negative 1/4 is about right there. And I know this parabola opens down. So the focus is at negative 1/4, and I know that's going to be negative. And the equation for the line is y equal in this case. I'll take the number in front of the square and set it equal 1 over 4p. Negative 8p equal 1. Remember, the significance of p being negative indicates the graph open, down, or up. We already know that. So if I am at 0 and I moved 1/8 of a unit down and 1/8 of a unit up, so negative 1/8 and 1/8. And there it is. It's simple if you know what you're doing and what to look for. A bit of a work if you're not. And how about that problem? Well, I need to complete the square. Y squared minus 4y plus 20 equals, I'm going to move that to the other side. Take half of the middle number, which is 2, and square it. This becomes y minus 2 squared plus 20 equals 8x plus 4. 8x equals y minus 2 squared plus 16 divided by 8, y minus 2 squared over 8 plus 2. Now again, if you're used to this graph, very good. Go ahead and jump straight at it. Tell me what the vertex is, sketch a graph, and proceed. If not, it does worth me doing this extra work and saying, let's say y equal x minus 2 squared over 8 plus 2. I know this parabola looks 2 units to the right, 2 units up, and it opens up. I know the vertex is at 2, 2. I know the focus is at 2 and y equal. If I take 1 over 4p and set it equal to 1 over 8, cross multiply and solve, p would be 2 units. If I am at 2 and I move 2 units above, 2 units above 2, that's a 4. 2 units below 2, that's a 0. Now, my actual graph. So all of this green work is extra. You don't have to do it if you're really comfortable with this, but if you're not comfortable with this, the vertex, switch x with y. The focus, switch x with y. Let me move this to the bottom. Here we go. And the directrix, switch x with y. And we know that a graph can never pass across the directrix, and it must include the focus. So that's pretty much it for parabolas. Ellipses shifted. Well, 2 ways of doing this. One way, and again, you really don't have to do this, but this is just my recommendation if you're having a hard time with this. So one way of doing this is for you to do this extra work, and you really don't have to. I would add an extra graph in there without the shift. And look how complex that is. In the x direction, 3 to the right, 3 to the left. So the center is at 0, 0 here, based on what I have. 3 to the right, 3 to the left, 1 up, 1 down. The vertices are at 3, 0, and negative 3, 0. The foci is the square root of 9 minus 1, which is radical 8, 2 radical 2 to the right, negative 2 radical 2 to the left, and the major and the minor. The length of the major axis, 3 to the right, 3 to the left, 1 up, 1 down, is 2 units. Now comes the actual, so everything that you see is extra. It's not needed if you're comfortable with those. I know the center is really 2, 1. So what that means, I'm going to take all of these x values and I'm going to add 2 to all of them. So the vertices will be 3 plus 2 is a 5, negative 3 plus 2 is a negative 1, foci 2 radical 2 plus 1, and negative 2 radical 2 plus 1. There it is. I am going to add a 1 to all of these y's. So all of these y's are going to be, instead of a 0, a 1. Now look how complex the graph is. I'm going to go to 2, 1, 1, 2, 1, and I'm going to do exactly what I did. I'm going to move 3 units to the right, 3 units to the left, 1 unit up, 1 unit down. Do you notice here, I didn't label, I should have. Radical 8 is a number between 2 and 3, so the focus is right there and the focus is right there. So I went from the center between 2 and 3 units, from the center between 2 and 3 units. Everything's labeled. I got the graph. Oh, and the major and the minor don't change. The major length is 6 and the minor is 2. So again, the blue is not needed. If you could do this without, I'll do the next problem that way. This is a graph that's shifted 1 unit to the left, and 3 units up. From this point, I'm going to move 2 to the right, 2 to the left, 4 up, and 4 down. There's the graph. Graphing is the easy part. Labeling is the hard part. So you did the graph. You're in very good shape. Well, guess what? I need you to tell me what the center is. Well, I know the center is at negative 1, 3. I need you to tell me what the vertices are. Well, again, see, now you have to count. You have to say, I'm going to go here, let's see, from 1, 2, 3. I'm going to go 4 above, that's 7. And 4 below, that's negative 1. The foci, I'll get those in a minute. They are at x equal negative 1. And the major and the minor. Major, the length of the major axis is, you went 4 above, 4 below, that's 8 units. And the length of the minor axis, you went 2 units to the right, 2 units to the left, that is 4. Now, square root of 16 minus 4 is radical 12, which is 2 radical 3. So if I am at y equal 3, if I move up 2 radical 3 and down 2 radical 3, the y value will be a 3 plus 2 radical 3 and a 3 minus 2 radical 3. And there it is. Now, I could have done this. I could have said, look, even though this seems like to be a lot of work, but it's worth it if this is confusing to me. I am looking at a graph that moves 1, 2, 3, 4 up, 1, 2, 3, 4 down. So center is at 0, 0. The vertices are at 0, 4, 0, negative 4. There's the graph. The foci, I already figured that out. That is right there and right there. That is at 0, 2 radical 3, and 0, minus 2 radical 3. And now all what you do, say, look, add a negative 1 to all of these points. Guess what? Here they are. Add a 3 to all of these points. Notice 4 plus 3 is 7, negative 1, plus 3, plus 3, and there it is. Everything's labeled. So it does worth an extra graph if you're having a hard time with this. And if they gave me that in general form, well, I need to get the x's together, the y's together, move that over. To complete the square, the leading coefficient must be a 1. You have to factor that number out. You have to factor that 3 out. Whatever number I add right there, that number is multiplied by 4. To keep this equation valid, I must multiply this by 4 as well. Whatever number I add right there, that's being multiplied by 3. To keep this equation valid, I multiply that by 3. This will be 4 into, and take half of the middle number, which is 1, and square it. Half of the middle number, which is 1, and square it. So this will be 4 into x plus 1 squared plus 3 into y minus 1 squared equals 25 plus 9. What is that? 25 plus 7, 32. I'm changing that problem right there. I'm making that at 29 just to make things simpler a bit. So 29 plus 4, that's 33, that's 36. So to make that a 1, I didn't think of that when I made the problem up. This will be x plus 1 squared over 36 plus y minus 1 squared over 12 equal to 1. So again, if you're comfortable with this, it's up to you. If you're comfortable with this, I will say, well, the center is at negative 1, 1, negative 1, 1. I'm going to move 6 in the x. 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6 to the left. And I'm going to move radical 12. Radical 12 is a number between 3 and 4. So 1, 2, 3, 4, somewhere in there. 1, 2, 3, 4, somewhere in there. I would label those if I was you. If I'm not going to sketch another graph, I would say, look, I started at negative 1, 1. I went from negative 1, 6 units to the right. That's 5. From negative 1, 6 units to the left, that's negative 7. You could do that. Now, no need to label those because I don't need them. But if I wanted to, that would be 1 plus radical 12 and 1 minus radical. That's not needed. Foci. Square root of 36 minus 12, which is square root of 24. That's 2 radical 6. Square root of 24 is a number a bit less than 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. To label those, well, remember, I'm starting at negative 1. I went from negative 1 and I added 2 radical 6, and I started at negative 1 and subtracted 2 radical 6. Now, the length of the major. The length of the major is, well, let's see, I moved 6 to the right, 6 to the left, that's 12. And the length of the minor, remember, I went up radical 12 and down radical 12, that's 2 radical 12. You could simplify if you want, take a 2 out of that, or 4 radical 3. It doesn't really matter. Those two are saying the same thing.